Hi, welcome back. We are doing notes for section 2.6 today, and it is page 64 in your note guides. Now, for some reason my video completely messed up when I was at the very end, so I already have my notes filled in today. I really apologize because I know some of you like to fill it in with me. So I'm going to try to go through it one at a time. Again, it's 2.6 and it's page 64 in your notebook. The addition property of equality. The first thing I would kind of do is you could put A equals B in for all of these. If A equals B in the first four sets, then we want to know what happens. And then I wrote A equals B over here for both of these, and then I put the plus C in at the end in a different color. So the addition property says if you know A and B are equal, and you add C over here on the left, you need to add C over here on the right because you keep it balanced. So remember what you do to the left, you do to the right, and I'm sure you've heard that before. Same thing here with subtraction. If A equals B, then A minus C is going to be the same as B minus C. Subtract on both sides. The multiplicative property is going to be, well, if you have A times C, then you have B times C. It has to be equal. And the division property works the same way. A divided by C would be equal to B divided by C. Now this only works as long as C is not equal to 0. I might go faster than I normally do, so again, pause if you ever need to fill in stuff and listen as you go. The next two, this one is our distributive property where you take that A and you distribute and multiply it through. So A times B plus A times C is going to be the same as that. Our substitution property means that if A and B are the same, I can replace A with B in any expression because they're the exact same. It's kind of like if I have a $5 bill or I have 5 ones. I can replace those in my wallet and I'm going to have the same amount of money. Reflexive property is like a mirror. So if you have a mirror, reflexive is when you see yourself in the mirror, so A equals itself. Symmetric is when it switches, so if A equals B, then B equals A. And our transitive, this one's kind of like syllogism that we did the other day. If A equals B and B equals C, then, because those are the same here, A has to equal C. So you know that because that's our syllogism or transitive property. We're going to use these, and those are all algebra properties. Most of you already know them. We are going to use properties of equality now. So our properties of equality, we're going to use these properties to fill in a proof. Our proof is a 2-column proof where the left side are your statements and the right side is your reasons. Your reasons justify your steps. Now, because we're using algebraic properties today, this is really nice because you already know how to solve these equations. These are equations you've been doing since pre-algebra and algebra, and now you just have to tell me why you were doing them over here on the right. So this equation is already here. I already have this equation here. I highlighted in yellow. That always goes first. Whatever you're given goes first, and the reason for it is because it's given. Now, x equals 7 is what we want to prove. Now, that goes in our last statement. However, the reason for that is never going to be, and I'll get to that in a minute. Anyway, here I'm adding to both sides. So I add to both sides to get to the next step, so I say that's my addition property. And then when I have 4x equals 28, I have to divide on both sides to get to x equals 7, so that's my division property. Now I have here, one of the most common mistakes made is that people want to say that that's given because it was given up there, or it's never going to be given. 100% of the time, the last statement is never going to be given, so just kind of remember that. And a lot of people like to say prove, because I said prove up there. Never going to be proved either. So those two are never going to be your reasons. It has to be how you got from the step above to that step. What did you do? Okay, I'm going to pause and we're going to go to the next page. Okay, we are not going to do all of the problems today. We are going to do 2, and then we're going to do the last one. I think the last one's number 5. So 2 and 5 over here. So if you want to pause and try to work them out on your own, do that and then see about the check. So the first reason is given. And then what I'm going to do first is get rid of that 2. So I subtract the 2 on both sides. And then here, because I have this number on the bottom, I'm going to multiply both sides by -6. So when I multiply both sides by -6, that's what I had to do to get to that last step. Okay, we're going to go down to the number 5 question. Now, number 5, there were two things I want to kind of show you on it. Distributive property. So we distributed the -7 and the 6 through. And then next we're going to kind of clean up these numbers, because you can clean up some of this over here on the left. So if I'm going to clean that up, I usually say it's simplify or it's combining like terms. I prefer to say combining like terms there. I think it's more appropriate. Okay, now down here, if I use what they had written, that would be subtraction. I took the -12 and I subtracted it over here to get -15. So look at my purple. And then here I'm going to add the 14 over to get -10. And now I'm going to divide by -15, negative over negative, be positive, and then you reduce it, 2 over 3. That's how they had it written in the actual set of notes. My problem with it is that I personally want my variable to be positive. It's just a thing. I like my variable to be positive when I can make it happen. So I would have added the 3x over here. And if I added the 3x, I would have had this. So I would have said addition here. And then I still would have added the 24 over here. And then I still would have divided. So this is the only one that would have technically changed. But again, depending on you and your proof, and if you're filling in the whole thing, if I give you a proof, I'm going to give you statements, so you'll have to go a certain direction probably. But it's just something to keep in mind. I'm going to pause and go to the next page. Okay, so these proofs are completely blank, and we'd have to fill them all in, but it's fine. They're algebraic equations. We know how to do these. So our given goes first, and then here I'm going to get that variable by itself, isolate the variable. I'm going to subtract 1. The subtraction property, I get -15. Now I want to get that x by itself again, divide by 3. And I get x equals -5. And I divide it. So you just say what you're doing. We are going to do number 2 as well. So if you wanted to pause, see if you can do it, and then come back and check. Okay, we start with 2 times x minus 9 equals -10. That's given. Now I've got to distribute that 2. So we're going to get 2x minus 18 equals -10, distribute. And then I'm going to add that 18 over here to get +8. And I've got one more step here. I'm going to divide both sides here by 2 to get x equals 4. And I divide it. So again, this shouldn't be new stuff. It's stuff we've done before. And we're just saying why. We are going to do 3. This is the last one we're going to do on this page. So go ahead and set it up. Pause if you need to. Here's the first step, given. I'm going to get rid of the 10 first, subtract both sides by 10. And then I need to get rid of that fraction in the denominator, so I multiply both sides by -3. And I get -3. Okay, we're going to go to the next page, and I believe we're only going to do 3 on that side as well. So again, if you need to pause or fill it in because I'm going faster, I apologize that I did that first video messed up. Alright, so here we are. We're going to do 5. Given. Again, pause if you need to. I'm going to subtract the 2x. If I subtract the 2x, that's going to keep my variables, or 2k, sorry. That's going to keep my variable positive. So I get ak minus 4 equals -20. And that was subtraction. Then I'm going to get rid of that 4. I add the 4 to both sides. So when I add the 4, -20 plus 4 will give me a -16 still. Now my next step, what do I do to get from here to the next place? And that's division. Okay, good job, you guys. All right, 6, I skipped. I'm going to do 7 and 8. So here's 7. We are going to distribute. Both sides need to be distributed. Okay. Pay attention to the signs when you do that distribution. So you get negative 8w minus 8 equals negative 5w minus 50. Now I want my variable to be positive, so I'm going to add the 8 to both sides. I added 8w to both sides. Negative 8 equals 3w minus 50. Now you have to move the 50. And now we're going to divide by 3. So we get, oh, that's a division sign. You may want to write division instead, or at least div. Okay, we have one last one on this page that we're going to do. Now, setting this up, the one thing I really think is important here is that you have this negative x out here. Hold on, I'm going to pause it for a second. Okay, so again, this last one now, we have the negative, you just have a negative there. But remember, you need to distribute that. So if you want to write a 1 there to help you remember to distribute that, it might be good. Again, pause if you need to, and then come back and check this one. I think this one ends up being a fraction at the end, I can't remember. You distribute the negative, 3x, negative times negative becomes a positive 34. Over here, negative 2x, negative 16. Okay, so here, now I want to clean up both sides. So over here, I can add the 14 and the negative 16 together to clean that up a little bit. I like the variable to go first, so I get negative 2x, and I get minus 2. Over here, I have variables I can add together. So you always want to clean up the left or the right first before you start moving things from one side to the other. So if I can add these together first, I'm going to do that. Now that I've got everything cleaned up on the left, everything cleaned up on the right, I want to get my variables together. So I'm going to take that negative 2x and I'm going to add it over here to keep it positive. And now I'm going to subtract the 34 over here. I get negative 36 equals 4x. And now I divide to get x equals negative 9. Okay, so that's it for the actual working out of the problems. The next page is matching. So go ahead to the next page, see if you can figure out the letters that go in each place. I'm going to try to do it one at a time with you. So if you can figure out the letters, and some of them are a little bit tricky. Okay, so again, one thing I mentioned in the earlier video is that some of us like the video notes because you can pause it and you can go at your own speed and you can go back and listen to something again if you need to. A lot of people said they didn't like that they can't ask questions. So again, put sticky notes on your notes, or highlight something, or write a little question on red off to the side. Say, oh, ask Miss Muchow. Come back to class and ask at the end of our class, or come back to office hours, and I'm more than happy to go over any of the notes and point things out to you if you'd like to come back. So go ahead and filling this in. The first one was H, it was symmetric, where they just flipped. D is division here. You divided both sides by 2, so it was division. Number 3 is the exact same. It's looking in the mirror. That's G was your reflexive. 4 was, oh, I should use it. Okay, 4 was where you added 1 to both sides, so it was addition. All my answers, I just saw them all now. Okay. This one right here, those two were the same. So because they're the same, if A equals this and this equals C, well then A, or 10A, has to equal C. So that's that transitive property, which was I. The next one here, you distribute in. Distributive was E. This one, now this is tricky because 6y equals 24, and you think, okay, well, you're going to divide, and you get y equals 4. No, because that's not what they did. Over here, they said, well, if you take 6y and 24 and you subtract 3 on both sides, technically that's your subtraction property. They didn't solve this one. So you have to look at whatever it is over there on the then part. So that was subtraction. This one, they took the w equals 1 and plugged it back in. So because they plugged it in here, that's substitution. F was substitution. Alright, 9 right now. Oh, I'm going to pause for a second. Okay, I think we are on this one. This side we're going to multiply both sides by 2, so C was our multiplication. This one, again, 3x equals 2y, 2y equals z, so that's the same thing. 3x equals z is our transitive, which was I. This is another one that was a little weird like up top. 7m equals 35, it didn't divide by 7. They added 4 on both sides, so this one was addition property. If 2x equals 18, oh, and they swapped spots, that was our symmetric. Symmetric was h. This one here, they took that x and they plugged it in. When you plug it in or substitute it, that's our substitution as f. Here, m equals -2. Well, they've multiplied both sides here by 8. This is multiplication. Something equals itself, looking in a mirror. This one's reflexive. And the last one I thought was a little bit weird because it was backwards distribution, kind of. So I thought it was weird. You usually don't see it in the reverse. That's kind of factoring, but there wasn't a factoring choice. So we're going to go with distribution for that one. Now, you have an Alex assignment for this set of homework, but there's also the homework in the text, in the note guide that I think is really good and maybe better because I think the Alex one might be weird. So if you want to attempt the Alex assignment, you can. If you would rather do the assignment in your note guide, I'm going to give you a choice this time. And I'm not going to give the choice very often because Alex is going to be really good for a lot of the stuff we do. But if you wanted to do the homework in the actual note guide this time, you can do the 2.6 homework where the box is. It's on page 69 and 67. Now there's 9 and then 10, 11, 12, 13, 14. There's 14 problems and I think they're all really good problems. I don't think any of them are really tricky. So I think that the 14 problems are a really good set to do. So that's your option for homework is you can do the Alex or you can do this. If you do this, I need you to take a picture of it. You can even lay them out side by side. Take a picture, insert the picture to a Google Doc, and I'll allow for a submission on this assignment. So then you could submit it to the 2.6 assignment. So you either do the Alex or you do the submission, and it's one or the other. Okay, so let me know. Good luck. Hope things are going well, and I will see you in tomorrow's notes or class.